Okay, can anyone can confirm that my screen is visible?
Yes, it's visible.
Okay. So let's get started. Okay, so hello everyone, and welcome to our webinar on Unveiling, LemonDuck, Dissecting the Malware and its TTP. I'm Nandini Bharadwaj, the operating officer at Cyber Warfare Labs, and I'm very excited to have you all here with us today. So let's begin. Okay, so this slide is about our company, Cyber Warfare Labs. So basically, Cyber Warfare Labs is committed to addressing the cyber security challenges with real-time, hands-on solutions. Our visual and virtual platform allows users to refine their skills through plug-and-play practical labs and a diverse range of certification courses. So I guess you all can join us in strengthening your cybersecurity expertise with Cyber Warfare Labs. And here you can see an architecture. This is a basic architecture of Cyber Warfare Labs. This contains of blue team, purple team, and red team. Okay, so let's move to the slide. Okay. So before we dive into the main topic, let's introduce our speaker of today's webinar, that is John Surgeon. So John is a red team security researcher at Cyber Warfare Labs with an expertise in reverse engineering, malware analysis, and source code review. He specializes in Windows internal, has reversed several AV and EDR systems, and is currently working on AV EDR evasion project. So this is about our speaker of today. And from now on, I can say that without further ado, we can start our webinar. And I would like John to take over from here. Okay, so thank you all. I hope you will like this webinar. Thank you.
Hello everyone. I hope my screen is visible and my voice is audible as well. Can anyone confirm this?
Yes, John, your voice is visible, voice is audible, and screen is visible.
Okay, thank you, Nandini. Okay, thank you everyone for joining this webinar today. Today in this webinar, we are going to discuss about the TTPs of LemonDuck malware. We are going to briefly discuss about the TTPs, how it works, how the LemonDuck malware operates, and we are also going to analyze the malware sample that we got in our hand. So without wasting any time, let's just dive into the content because we need to cover many things today. Okay, so this is the basic kill chain, and so it has many vectors, attack vectors, but here we have simply simply depicted the important attack vectors that it is using. So for the initial access, we identify that it is exploiting the public facing applications or services. So in this case, what we did was we set up the vulnerable server, and we vulnerable Windows server, and there we set up all the vulnerable services and tools, and we also set up the RDP services with a very weak username and password, and we expose that server to the internet. And after a few days, we got our hand in this malware, and it turned out to be the LemonDuck. So, as looking at the history of this malware, were able to identify that it uses the various attacking vectors to gain the initial access in the system, like phishing attacks, supply chain attacks. But the mostly in our case, we observed that it was exploiting the public facing application, and it was also exploiting the public facing services to infiltrate our server. So this is solely based on the malware sample that we got. And also for the persistence, for maintaining the persistence in the system, they are modifying the default user password, and they are also registering the scheduled tasks, which we will be talking about this later in a greater detail. And also after getting the persistence in the system, they are discovering many informations from the systems, like IPs, MAC addresses, and different connections that's happening in the system. And they were also able to get the different user accounts from local and domain. And so it has discovered many different things, which we are going to analyze that in the malware when we jump into the lab. And the most important component that we uh, believe is the lateral movement for this malware. So what it does is, so basically, before mentioning about the lateral movement, let's just like know the motive of this malware. So basically, in general, this malware is the motive of the malware uh, is to mine the cryptocurrency in the victim machine. So in this case, what it does is they try to exploit the SMB vulnerabilities in the system. So at least in the sample that we got, they were trying to exploit the malware was trying to exploit the SMB vulnerabilities, um, to infect the to infect all the vulnerable machine in the system. So what they do is they will exploit the SMB vulnerabilities, and then they will propagate itself to the different victim machines in there. So we will look into this later. And for and this malware, this malware does not impact, mostly like it does not still it is still the credentials, but we will talk about this later. But the major impact that it does is it hijacks the resources of the system, because it needs to mine the cryptocurrency. So it is going to hijack some of the system resources, and definitely when mining the cryptocurrency, it will definitely degrade the performance of the system. So without wasting any time, let's just jump into the TTPs. And so let's look into the TTPs in the detail. So as we mentioned earlier, uh, it has many initial vectors that it can to access the system. Like it can do the phishing attacks, it can use the supply chain attack vector as well. But the most important that we identified in our server is that it was trying to exploit the public facing application, which was the SMB server, the vulnerable SMB server. So it was trying to exploit that vulnerable SMB server, as well as it was brute forcing the RDP user and passwords to get the initial access into the server. So from here onward, every details is solely based on the malware sample that we got. So for the execution, they were using the malware is using the command and scripting interpreter. So in which it is using the PowerShell. So for the execution, it is using the PowerShell, and mostly PowerShell is used to download and execute the additional PowerShell script. And other thing that PowerShell is being used is to disable the Defender's real-time monitoring, as well as executing the famous tool called Mimikatz. We will talk about this later in the next few slides. And another technique that it used for the execution is the Windows Command Shell, which is CMD. So it performs like the command is used to perform various operations like copying the downloaded file to different location, deleting the files, and it is also used to execute the bat script. And the command is also used to leverage the MSSTA. So actually the MSSTA is the legitimate binary. So it is used to execute that binary, and that binary is tricked into loading the malicious executable, so that it looks like the script was executed with the signed binary or legitimate binary. And uh, also for the command execution, so they are also using the MySQL server. So they are using the XP command cell feature of the MySQL server, which we will be talking when we analyze the malware binary. And also another technique that it uses is the system service. So they basically creates and start the system service and executes bunch of commands. So before moving into the next slide, what I like to mention is, if you look at here, this is the execution. So this is the tactics, and this is the technique, and this is the technique ID, and the description is how they are using the technique in their operation. So now the next tactics is the persistence. And for the persistence, three major technique that they use to persist in the system is valid account, server, software component, and scheduled tasks. But these three techniques are also used to escalate the privilege in the system. But additionally, for the privilege escalation, there is one additional technique being used. We will talk about this technique later. But this three technique is also used for the privilege escalation, and the same script is used. That means like they are not, it is not using the different same technique, but the different script. But actually, they are doing the same thing for the both of the tactics. So we will talk about like the motive of the author for creating this. We will look right into the motive of the technique that they use for this persistence and the privilege escalation. So for the of the first important technique that they use is for the persistent is to override the password of the default account. So they just simply change the password of the administrator user to this value. So from the perspective of the persistence, the motive of changing the account password is to persist in the system, so that it can execute commands later whenever they needed to. But if we look from the perspective of the privilege escalation, the main motive is to change the administrator user account so that it can execute the higher privilege core commands. It does not change the normal user's password. It only changes the password of the administrator user. That means from the privilege escalation view, the main motive is to change the password of the administrator. But from the persistence, from the perspective of the persistence, the main motive is to change the password of the user account. And another technique that they have used for the persistence and also for the privilege escalation is the SQL stored procedures. So MySQL server also supports the extended store procedure. It supports the CLR assembly. So what it does is it imports the CLR assembly into the server, and then they create a CLR store procedure, and they link the procedure to the CLR assembly, which is a C# binary, and it is named as the evil CLR.dll. So this assembly will be loaded into the SQL server first, and then they create a CLR store procedure and link that with the assembly. And whenever they need to execute the command, they will simply invoke the CLR stored procedure with the command they need to execute, and that command is going to pass to the CLR assembly, and CLR assembly is going to execute that command. So if we look at from the perspective of the persistence, the evil CLR that is being imported into the SQL server is the main motive, because they want to persist in the SQL server database, SQL server. But if we look from the perspective of the privilege escalation, um, the main motive is to execute the higher level privilege commands, like changing the user passwords and registering the store procedure as the system user. We will look into this later in the um, while doing the malware analysis, so that it will be very clearer when doing the analysis. And also another technique that they use for the persistence, and it is also used for the privilege escalation. So here what they do is they will abuse the task scheduler of the Windows operating system, and they register the tasks so that the tasks will be executed at some interval of time, and the scheduled task is going to execute either binary or the script, and those binary and script might be executed at some interval of time. So if we look at the scheduled tasks from the perspective of the persistence, is that they are registering the tasks in the task scheduler, and task scheduler is going to execute that command at some interval of time. But if we look at this technique from the perspective of the privilege escalation, they are registering the tasks as the system user permission. That means whatever they register in the task scheduler, they are going to register the tasks as the system user permission, so that whenever the task scheduler is going to execute the command, it will execute as the higher privilege. So, and one additional technique that is being used in the privilege escalation is the exploitation of the exploitation for the privilege escalation. So here what it does is it will scan for the SMB vulnerabilities, and it will exploit the if it finds the vulnerable SMB server, then it is going to exploit that vulnerable server, and then it is going to change the password of the administrator with the same user, and then it registers the tasks in a Windows scheduler with the system user permissions, so that next time when the task scheduler execute the command, it is going to execute those command with the system level privilege. We will talk about this SMB exploitation in the next few slides. It is also being used for another purpose as well. But before that, we will look into the defense evasion tactics that they have used in the malware. So they for the defense evasion, they are disabling the Windows Defender real-time monitoring, and they are also excluding the process PowerShell, because PowerShell is heavily monitored by the Windows Defender or any other security vendors. So they are excluding but for this one, they are just excluding the process in the for the Windows Defender, and the process that it excludes is the PowerShell.exe. So whenever the PowerShell is executed, it is expecting that Defender will not scan this PowerShell, and also it adds the C drive as the exclusion path. And another technique that they use is disable or modify system firewall. So here they add a new firewall with the name DNST, where it opens the TCP port, which is 65529. We will talk about this port later. Just remember this port; it is really interesting. We will look into this later in the malware analysis, while doing the malware analysis. And another rule that they have added is the web. So where they allow the inbound traffic to the port 445, and there are other rules that are registered in the we can see that in the malware sample, but those are not mention here because these two are important one. And also another thing that it does for the defense evasion is they use the technique. It use the technique system binary proxy execution. So if you look at this MSSTA, we just discussed about this earlier in the execution part. If you look at here, the command is leveraging the MSSTA to execute the malicious STA file. So here what it does is it proxies the arbitrary code execution through the trusted utility. That means this MSSTA is the trusted utility of the Windows operating system. So it will trick this tool into loading the arbitrary code, which is the malicious code, and it is being downloaded from the internet and directly executed from there. We will look into this later in the malware while doing the malware analysis as well. And another interesting thing and most common thing that most malware use is the obfuscated file or information technique. So this malware obfuscates the mimikatz tool. So it is not going to obfuscate the actual mimikatz binary, but it obfuscates the invoke mimikatz PowerShell script from the power exploit, I think. And that PowerShell script is first obfuscated, and that obfuscated code is then compressed. And after compressing that code, the buffer is the compression buffer, whatever the output from the compression, that buffer is encoded into the base64, and that base64 is embedded into the main program itself. So we will look into this in the malware while doing the malware analysis as well. And for the if the malware is using this technique, they must have implemented the deobfuscation mechanism, because let's say we compress the mimikatz tool, and if we just pass that buffer into the into the PowerShell as a parameter, then it is not going to work because it simply does not work that way. It needs to be deobfuscated, uh, and it needs to be converted uh, into the original form, or maybe the intended way, like how it works before obfuscating. So it needs to convert in its original form. So that's the deobfuscation. So in this case, what they do is first they will decode the base64 encoded buffer, and then they will decompress the deflate stream, decompress the compressed buffer using the deflate stream, and then it is going to obfuscate the obfuscated PowerShell script, and then the mimikatz will be invoked. So one interesting thing that they does is they first dump the mimikatz, the PowerShell script, which is compressed version of it. So it's simply going to dump that into the file m2.ps1, and it is later get invoked from the application, and the deobfuscation will happen. And also another technique that they use is the reflective code loading. So the PowerShell script is not a mimikatz tool itself, it's just a loader. So it is going to reflectively load the mimikatz tool in the memory, which was previously dumped into the m2.ps1 script. We will look into this later in the malware analysis too. And for the credential access, they are definitely using this mimikatz tool, which is a really famous tool for dumping the OS credentials. And here they have implemented this mimikatz tool, the execution of this mimikatz tool, in a really cool way. So what they does is they will execute the mimikatz only after the interval of around like 6 days and 6 hours. So it is not the accurate time, but at the time of this interval, the mimic as will be executed, and it will extract all the domain, username, password, and any other credentials and dump into the file. And another is the discovery. So the malware sample collects IPs, MAC addresses, and all the connections that's happening in the system. It will extract all the IPs from there, and it also scan for the network to find the vulnerable server, which is really vulnerable to the eternal blue exploit. And it also looks for the valid user account and usernames. So it looks for local account and domain accounts using these tools, net user, net local, these tools, and command like net user, net local groups. And it also scans for the specific process using the WMIC tool. And we will see this later in the malware analysis, while doing the malware analysis, how they are using the WMIC to discover a specific process and for what purpose. And for the lateral movement, if we recall from the privilege escalation, it was using the SMB exploit, the eternal blue exploit, to escalate the privilege. But it also uses this technique, the eternal blue exploit, to laterally move or propagate itself to the vulnerable machine. So what it does is it simply exploits the vulnerable machine, and it upload itself into the exploited machine, and then it executes from there, and do the same thing, and it just spread itself using the SMB exploit in the network. And it is using the couple of tools, like it is using the lateral tool transfer technique. So it uses the PS exec to upload the file and download the file into the victim machine, and it also upload itself into the exploited machine through the SMB. And so for the exfiltration, they are exfiltrating the details like PC name, MAC addresses, IPs, through the URL parameters. But one critical information that it um, exfiltrate is the password that is dumped by the Mimikatz tool, and also the users, which is not mentioned here. And after that, the impact is in the resource. The major impact is the resource hijacking. So they hijack the system resources for mining the cryptocurrency, and the cryptocurrency that it mines is we actually didn't get a hand on the actual mining binary or script, because at the time of analysis, the subdomains were down. So we are expecting that it is mining the XMR cryptocurrency in the system. So here are the few indicators of compromised IOCs. So you can look into this later. But for now, we are simply going to dive into the lab, and we are going to analyze the actual malware sample. So initially, the malware sample that we got in our hand is not the Python script. Actually, it was the binary which is packed by the PyInstaller. So this is the original Python script. So it was packed with the PyInstaller to convert the Python script which converts the Python script into the executable. So we got our hand in that executable, and we extracted and decompiled this Python script using a couple of tools. And this is the actual Python script for the malware. So we have also bookmarked the location where we are going to analyze the malware, because we do not want to get lost during the analysis. So we have marked these bookmarks like step 1 is step 2. So from there we are analyzing the component or flow of the program. So for the step 1, what they do is, whenever the program is executed, whenever the malware executes, it will check whether the file that it is currently executing is the latest version or not. So in this case, it is expecting that there must be the memory which is tagged by the path. So it will look for the memory which is tagged by the path, and then once it finds, it is simply going to read the buffer from the memory location. So this is actually a shared memory. So in this case, if it is a first instance of the malware, then it is not going to if it is the if it is the first instance of the malware which is running in the system, then all the buffer it returns here is a null bytes. That means and here we are it is replacing all the null bytes with the empty string. And when it replaces every null bytes, the string will be empty string if it is first instance of the malware. And in that case, the length of this string will be 0, and 0 is always less than 4. So it is going to enter into this if block, and it is going to map the anonymous memory, which is a shared memory, and it's shared between the multiple processes. And this memory will be the tag name for this anonymous memory will be the path, if you look at here. And in the memory, once it allocates the memory, it is going to write the file name which is currently executing. The argument 0 is always the file name which is executing currently. And so this is how they write the path into the newly allocated memory. So first they will write the malware, and then as a separator they are writing the double asterisk sign here, and after that it writes the version. So if you look at here, the version is 20, and after writing the version it will again write double dollar sign here. So this is the pattern how it writes in the memory. Now let's just assume it is running, the application is running, and next time let's say we are also assuming that it has the auto update feature. Let's say somehow it got updated, and the malware that is now being executed is the 21, and let's just assume that the version 20 of the malware sample is still running in the uh, system. In that case, the version 20 has already created the memory map with the tag name path. So in this case, it is not going to return all the null bytes. It is going to return the path name and the version name, which is previously written by the malware sample with the version 20. So here we are expecting that is the newer version which is currently running, and the previous one is just assume that it is still running in the system uh, in the system, and now it is the current process, and the current version of the current process is 21. So in this case, the buffer that it reads will be the path name and the version 20. And then it will never going to enter this if block, and from here it is going to get the version which is written by the um, old version of the malware sample which is running in the system, and the version will be 20, and it will also extract the actual path of the uh, malware of the old malware sample, which is also written by the old malware itself in the memory. And then it will check whether the new malware sample, it will check the MD5 of the new malware sample and the MD5 of the old malware sample. If it is equal, then they are the same version. Otherwise, we are assuming that it's the newer version. So the version is 321 and the old version is the one that we just retrieved from the shared memory, and the old version that is running in the system is the version 20. So version 21 is greater than version 20, so it knows that it is the newer version that is running currently. So it will just open the command and then it will kill the tasks. That is, it will just kill the older version of the process which is running, the version 20. And then again here it is scanning the process with the same name, which is the same name that is written by the version 20 here. And again it is terminating. After terminating, it will just ping the local host just to make sure that just to like allocate time for itself, so that the system has terminated the process. And after that it is again going to look for the same process, and it will delete the file. It will delete the file of the actual file of the process, and then it is going to copy the new malware sample into the same location where the so new malware sample is the version 21. So it is going to copy itself to the same location where the version 20 was, and then it is going to write the um, random it is going to write the random name to the file. And after that, after replacing the binary there, it is going to schedule the tasks. If you look at here, it is using the SCS tasks to uh, schedule the tasks in the system. So here it is checking whether the PowerShell this directory is present there or not. If it is present, it is going to create a task with a name. It talks with the name update, and then the user, if you look at here, it is trying to register these tasks as a system user, and then for every 15 minute at 7:05 a.m. it is going to be executed, and the binary that is going to be executed is the newer malware sample. Sorry, the newer malware version, which is just being replaced with the old one. Otherwise, like if there is no Windows PowerShell, it is going to start the scheduling, and then it will wait for a few minutes by pinging the localhost. Sorry, few seconds by pinging the localhost, and then it will scan whether the schedule service is running or not. And after that, it will delete the e-scan task from the task scheduler, and then it will again create a task with the system, with the user system, and then for each 15 minute it is going to be executed, and this is going to be invoked at 7 a.m. in the morning. And then the task name that it register is as escan, and the binary that it is going to be executed is the latest version of the malware. So here basically what it does is it checks the version of the malware sample, and if like the version which is currently running in the system is the older one, then it is going to simply kill that process. It is going to delete that older malware, and it is going to replace the newer malware in the same location where the old malware was, and then it will register the task to execute itself. And after that, it will check whether this is the single instance. So if we look at here it is just checking, it is just creating the mutex, and here it is trying to create a mutex. And if the program is already running, the mutex will not be created. That means it will, if the another instance of this program is already running, then it will simply terminates, because the malware is expecting that there is no other instance of the program running at that time. and there it does not, and it is not required to, it is not expecting to run a multiple instance of itself. That's why if the instance is if the first instance of the application is already running, it is simply going to terminate. Otherwise it is going to initialize all these um, IPs and usernames, passwords. So these are some of the known username and passwords which is used for brute forcing the username and password later. Now we will look into the step 2. So step 2 is also similar to the step 1. What they do is they will in this directory C Windows, they will scan for the file with the file size 6271136 bytes. So it's around 6 point something MB. So if it finds the file with the same size, then it will simply kill the process, and then it will delete that file, and then it will copy itself the latest version of the malware sample to the same location where this file was, where the file with the size 6271116. We are assuming that the file that it is scanning here is the really older version of these malwares. So it is just deleting and replacing with the newer one, because it's just a 6 point something MB, but the files, but the size of the file that we have in our hand is around 7.5 MB. That's why we think this is really old sample and it is replacing that. Okay, so for the step 3, what they does is they scans the domain, and they scan for the user in the local group, administrator user in the local group, and here it is parsing the output and then extracting all the admins in the local group, and here it is scanning all the admins in a domain, and here it is listing out all the domain user from the output to the domain admin list. And here one thing that it does is it is executing the command using the psexec, and here what it does is the domain admin that it just received from this command, all the it is trying that the user that they have retrieved from this command, they are trying the password 123456, and the other is password, they are trying the password as the password. So if the user that it just retrieved from here has the password 123456 or password p, or the just a plain text password, then if this command successfully executes, it means that the domain admin has the password 123456 or password. So but it is highly likely not going to happen, because domain admin because the password of the domain admin is not going to be like this 123456 and password. But if it is, then it's really serious issue here, because now if the domain admin has the password 123456 and password, then they can simply um, escalate the privilege with the domain admin. And in the step 4, they are going to execute the mimikatz tool. So first it will check whether there is a PowerShell directory there. If there is a PowerShell directory, then they are going to check whether there is the m2.ps1 file. So let's say we are analyzing this file and we do not know what the m2.ps1 file is. So in that case, we will see like what happens when the file is not in the directory. So let's just assume that we do not know about the file m2.ps1. In that case, we will just go and look into the else block. And in the else block, if you look at here, it is opening the file with the right permissions. That means it is basically creating a new file with the right permission. And the mcats, if you look at here, I'm just going to click here. This is a whole encoded blob of the mimikatz invoke mimic as PowerShell script, which is compressed and encoded with the base 64 as we discussed earlier. So this is the mimic as script, which is compressed and encoded. So the whole buffer that we just saw, all this is going to will be written in the m2.ps1. So if you look at here, if the file does not exist, it is going to open the file m2.ps1 with the right permission, and all the buffer which is in the mcas variable, it is going to be written into the file. And then after it is written in the file, it is going to check whether there is the file name mcas.ini. So if this file does not exist here, then again it is going to execute the m2.ps1, and after executing the mimic as, so this is how it looks like. Let me just, so this is the obfuscated version of the mimic as, and this is the, so it's flagging as the malware. So if you look at here, this is the malware, this is the mimic as tool, which is decompressed and deobfuscated. So here it is going to invoke that mimic as reflective loader, and whatever the output it gives, it is simply going to write that into the file mcas.ini. So this is how the output looks. So after executing that mimic as, this is how the output is going to be written there. So now let's just go over here. Now we know m2.ps1 is the mimikaz tool, and mcas.ini is the output from the mimikaz tool. Now if the both file is present in the disk, first it is going to check when the file was written in the disk, when the mcas.ini file was written in the disk, and it is also going to retrieve the current time. And here it is checking whether the file with mcas.ini file, which was written in the disk, is the file before the it is expecting it to be. It is just checking whether it has happened 6 days or 6 hours. So it's just checking if the file is written into the disk and it's been more than 6 days and 6 hours, then it is simply going to reload the mimikatz tool, and the command that it is going to execute is the secure lsa logon password.exe, and then the output is this one. So this is the output for that command. And if the mimikatz has been executed for more than 6 days 6 hours, if the file, this mcas.ini, the file is in the disk for more than 6 days and 6 hours, it is going to re-execute the mimikatz, and the default command that it for the mimikatz is this command, and the output will be again rewritten into the mcas.ini. If the file is in the disk for, let's say, less than 6 days, then it is not going to execute that mimikatz, because executing the mimikatz frequently is going to create a suspicious events, or maybe it is going to be flagged somehow later in the. So they are just maintaining the stealth here. So after every 6 days and 6 hours, it is going to update the output, and it is not going to execute the mimikatz tool before the 6 days and 6 hours. In that case, they are simply going to read this file, and it is going to read this file and extract the information here. So the information that they extract is, they will look for the lm star and lm, and from there it is going to extract the username and the password, and so, and also the domain, And the password, it is going to append all the passwords and user in the password list and domain user domain user list. And also it is going to extract the star anti-lm, and all the anti hashes will be extracted and appended in the anti list. So this anti-lm is the output will be when when the system is in the domain. But for now, in our case, the machine was not connected in the domain, so this is the anti-lm. So this is what they are extracting there. So all the hashes were extracted and appended in the list for the anti-lm, and then for the lm, it is not present there because the system, whichever system we have executed this mimikatz2, it is not present here because it was not connected to the domain. So for the mimikatz, it is going to be executed after every 6 days and 6 hours, and the mcast.ini, the file will get updated with the newer version of the username the password or something like that. Otherwise, for the 6 days and 6 hours, the mimikatz tool will not get executed. Only the output will be read and extracted. For the step 5, what we are going to analyze is the discovery and exfiltration. So what they does is they will extract the MAC address, all the passwords. So if you look at here, this pass.dict, it is from the mimikatz tool. If we look at here, the function, so the output from the mimikatz tool is all these are joined in as the and it is joined and assigned to the mpass. And then if you look at here, all these variables are passed to the C2 server through the URL parameters. And so here is the one interesting thing that it does. So whenever it exploits or it infects some system, it is going to write one of this file. It is going to write the star, this asterisk sign in one of these file. So if let's say if the system in the network was exploited or maybe infected through the domain username and password, after brute forcing the domain username and password, then the FRO variable will be set to the domain. And if the infection was done by abusing the local administrator user and password, then FRO will be set to the IPC. If the infection was done by the anti-hashes, then FRO will be set to the hash. And if the infection was done by the MySQL, then the star will be written into this file and FRO will be set to the MySQL. So it is simply like checking whether this file exists or not. If this file exists in the system, that means the infection is done by brute forcing the domain username and password. And if the IPC is present in the disk, then the infection is done by brute forcing the administrator passwords. And same thing for the hash and for the 143 as well. And if there is a file eb.txt, that means the system is infected with the eternal blue exploit. And if there is a do admin.txt file in there, that means the default username and password for the domain admin was 123456 and password as we saw before. And using that username and password, the machine was infected. So in that case, FRO will be set to do admin. So if you look at here, so if you look at here, the domain user and password, it's brute forcing the domain user and password and executing the ps exec. Username and password is passed here. So here, if it successfully brute force the domain name and password, then the ps exec command will be executed successfully. That means it has exploited with the SMB. The system was in fact exploited with the domain username and password by brute forcing it. And upon successful execution, if you look at here, the star is written into this domain.txt file. So this is like a marker, this is like a marker how like the infection is happening in the system, something like that, like a checkpoint. And after this, here's a function named with cul. So this is also almost the same thing. Here they are looking for the shared memory with the tag name 716 something something. So they are just checking whether they will just retrieve the file path, and here they are checking whether the file path or the memory, whether the buffer read from the memory is greater than 4 or not. If it is greater than 4, then it is simply going to split the path as the .exe, and it will simply open that with the exe, the first byte with the exe, first index of the first element in the list with the .exe. And if you look at the name, there's a dig equal to 1. This means that the file that it is looking for is the dig, because if we just search for the dig.exe, we can see the file is present here, and it is checking whether the file dig.exe exists or not in the system. So probably by looking this name, we can assume that it's the dig.exe. And so here it is checking where if the file path is present in the system, then the dig equal to 1, and otherwise if that file is not in the system, it will just set the value of the dig equal to 0, which means that the dig is not present in the binary dig is not present in the system. So here it is simply going to pass that value here. If it passes the value 0, I think the server is going to provide the link to download the buffer dig.exe. So that's why they are also passing this information in the URL parameter, and based on the 0 and 1, it is going to determine whether the file is there or not. We are also assuming that this binary is related to the crypto mining tool, but we at this point this subdomain was down, so we are not able to get any information on this file. And also same thing for the another one, that is DL. So it's doing the same thing. If the MDL is set to 1, it is then passed to the server, and based on this it is going to return some response. So if the MDL is 1, that means this binary is already in the disk. But if it is 0, then this binary is not in the disk, so it is simply going to give some maybe URLs or something to download, to further download this tool. And at the time of analysis, we didn't get our hand into the output from this domain subdomain, because it was down at that time. But here what they are doing is they are passing some of the variables, and based on these parameters, it is going to return some buffer, and there is a tool called command reader which is going to parse this buffer and get the command from there. So at the time the subdomain was dead, but we were able to find one lead here. So in this sandbox, this is a really old analysis, which is, I think it's the a variant of the same sample here. So the output that it gives, if you look at here, this is if you look at this, the URL, it is similar to the one that we just saw here. This, if you look at here, the first URL is the parameter is the ID, and then MAC, and then OS, and also the URL looks similar, only the domain is different. So the response that we received, not we, but the response that we found here is this response. After if the domain was present, we would have gotten this kind of output, but the subdomain was down, so we didn't get any output. So we analyzed this output with the same command reader file. So this is the output, and if you look at here, this is the base64 encoded string, and this is splitted with the $sign here. So there are two base64 encoded string. One is this and another one is this. So it is then passed to the this get command function, and from here it is going to decrypt that file. So if we look at here, it is the RC4. So if you look at here, it is we can conclude that it is encrypted with the RC4. So using the RC4, it is going to be decrypted. Both of the blob is going to be decrypted with the RC4. So we can simply copy this for now. And if we go to the cyber safe, let's paste it here, and this is the base64. So we need to decode this first with the base64, and it is encrypted with the RC4. And the key for the RC4 is the non-public key, because we didn't pass any public key from here. So if we paste it here, if you look at here, we saw the MD5 hash and then the URL. And this is formatted as the dictionary like this, using this script of using this loop. It is formatted as a dictionary. And here it is simply going to check the MD5 of the current file with the one that is in the command. So this is the I is from the P, and P is from the PNGZ. PNG is appending the command in the dictionary that we just saw here. This as this. So this is appending. So based on the, let's say if there is a if the dig value is 0 and MDL value is 0, then it might return two blob of base64. So in that case, we could have two MD5 hashes and the links to download the file. And if you look at here, the file is downloaded as the so here the down e function is responsible for downloading the file. If you look at here, it is just opening the URL and then reading it as it is reading it and then writing it to the file name. And if you look at here, the file name is open as the file name is retrieved from the URL itself, and the file name will be the buffer will be written into the file. And then after successful download of the binary, maybe it will be DL or maybe MDL or any other binary, the here the next thing that it does is it will simply copy that file and rename this as the update.exe and then execute the binary. So this is what it does. So here bunch of checks are going on, and if you look at here this and right after the first loop, if you look at here, this is the infinite loop while one. So after it reach here in the first iteration, it is going to sleep for 1 hour, and then it will increment this variable with one, and then again start from the beginning of the loop. So in each in like in every 1 hour, it is going to execute all of these from the beginning of the loop. And here the new thread is created for that function to execute. Now we will analyze the last step, which is the step 7. So here what they does is they will find all the IPs. If you look at here, it is looking for all the IPs from the ipconfig all command, and here it is also finding the IPs from the output, and it is excluding this IP here. So if the IP starts from 127, 255 or 0, it is just excluding that. And all the others are, it just extract the network ID. Let's say from the ipconfig slash all command, we retrieve the IP 192.168.10.50. Then here it is splitting this by dot. That means first it will retrieve the first value 192, and second 169, and third 110. So here it is just extracting the network ID. So it is not extracting the host ID. Then it is replacing the host ID by 1, and then with the subnet 24. Now the IP 10 will be converted to 192.169.10.1/24. So this is how the information is stored in the list, in the IP list. And same for the other IPs, which is retrieved from the netstat NA. All the connections that is happening in the system, all the IPs will be extracted, and it will do the same thing for those IP as well. Also, it is scanning the global IP, the public IP as well, using these two URL. So after scanning the IP, here it is going to find the start bit and the end. Let's say the IP is 192.168.10.1. So it will split the IP and CID here. So in this case, if it is 10.1, it will first calculate the start bit. That will be maybe 0 and 0. This could be the start. This could be the start IP address, and it will find the end IP address, which could be 192.168.10.255. So here it is going to go from this IP to this IP, and then in each loop it is going to increment the host name by 1. So in first loop it will be 0.1, in second loop it will be 0.2, 0.3. It will go like this, and in each loop it is creating a new thread, and in that new thread it is calling the scan SMB function with the IP and the 45. So IP is from the I value, which is the one that is incremented. So in each IP it is going to scan the SMB, the IP and the 445. So let's say it is the IP 192.168.10.2. Then it is simply going to scan the I scan the port whether 445 port is enabled or not. If you get here, it is scanning in the IP that port 445 is enabled or not. If it is enabled, then it will determine the SM that the machine that they just scan that it just scan has the SMB port open. And here, if you remember, so we mentioned in the defense evasion, the 65529 port was open. So here they are scanning this port again. So whenever the machine is exploited, this port will be open. So if it returns 1, then that means the system with IP, the system with whatever IP is passed here, and if the 65529 port is open, it will return 1. That means this the system with this IP is already exploited, so it will not going to try this. It will just going to skip this. If it is not exploited, then it will return 0. So in that case, it will go and validate with the default user password or brute forcing the password. And if that does not happen, it is going to call this function. So before that, let's just look into the validate. And if you look at here, it is just trying different username and password to execute this command. It is trying whether this username and password works. And also here it is brute forcing using all the passwords and username that we just that the mimic has or other hard-coded present in the binary. So it is just brute forcing. If it works, then it is just going to return. Otherwise, it is going to check again with the domain user and domain password. So here it is just checking before exploitation. It is just checking whether the username and password works or not. Because if that works, then there is no so if that works, then we do not need to like exploit. It does not need to exploit the SMB vulnerability, because exploiting the vulnerability is a little bit riskier, because it might break the server as well sometimes if it goes wrong. So that's why it is trying the passwords, brute forcing the passwords and all. And if that does not work, then only after that it will go and look for the vulnerability in the server. So if the port is open, it is going to scan the port whether the SMB is vulnerable or not to the eternal blue attack. So if it is vulnerable, then first it is here, as we previously mentioned, if the system is already exploited by the eternal blue exploit, then it is going to return 1. Otherwise it is going to return 0. So because this port is a marker, is the checkpoint, it will determine whether the system is already exploited or not. So if this port is open, then eternal blue exploit is already executed. Otherwise it is not. So in this case, if it is not, if it is equal to 0, then the system is not exploited. But again here, they are trying with the username administrator and password one more time before exploitation. Because sometimes what happen is, even like let's say we exploited this whatever IP is here, we have exploited this machine. The malware has exploited this machine, and it had opened the port 655, but somehow the port get terminated or closed. So in that case, like before running the exploit, what they are also expecting is that uh, even if the port is not open, they are also expecting that if it is already executed or it is already exploited or not. So they are also validating one more time by executing this ps command, ps exec command, ps exec tool. So they are validating whether the system is already exploited or not, because when it successfully exploits the server, it is going to add the administrator it is going to change the password of the administrator K8D3J9, this value. If the system is already exploited, but port is not open, in that case it will definitely going to work, because the exploited system will have the password for this password for the administrator. So this is just for the validation before running the exploit. So if it does not work, then only after that it is going to execute the exploit. After executing the exploit, it is going to change the, if the exploitation is successful here, it is going to change the user to the administrator. Sorry, it is going to change the password of the administrator to this value. And here again, after the exploitation, it is going to execute the psexec tool to register to open the port in the system. So if you look at here, this is the marker port. So if the system is exploited, it is going to open the port 65529. So this is just the marker port, and then it is forwarding the port. It is doing the port forwarding to the port 53, which is the DNS port, and the connect address is 1.1.1.1, which is the IP for the Cloudflare. And after that, they are downloading another script and executing it here. So if we just copy this, so after the successful execution, they using the administrator and the password K8D3J9S JF7. So if we just go over here and look at this, if you look at here, there is the HTTP. Just so if you look at here, it is also downloading additional script from the t.amynx domain, and it is invoking whatever it has downloaded. And we actually, at this point, it was not present in the domain was down. That's why we just trace back these similar kind of IPs in the sandboxes, and then we found the obfuscated sample there, like this. And this is the final version of the that obfuscated script, but this is actually the old version, and we do not know if it is still true for this current version of the malware. And so after that, it will just register some of the tasks. And so if we look at the exploit 2, it has passed the cell code, and the cell code that it is using is this cell code. So after the successful exploit of the SMB server, it is going to execute this cell code. And if we go to the cybersafe and paste that here from Higgs, and here if you look at this command, it is if you look at here, it is changing the administrator password to this one, K8D3J9, same password. That's why if it is if the exploit is if the exploit happens successfully, then this psexec is going to be executed without any issue, because this is going to change the administrator password to administrator and this password. So this is here, they are checking multiple times. If like something went wrong, they are doing the same thing again and again. Now after doing that, it is going to download additional script and execute it from there. And also one thing to show here, in the ps exec, it is actually copying this file dl. If you look at here, this dl, and if you look at it, the dl is coming from this value s, and it is checking whether the file dl, so it is the path. If you look at here, so it is the file name, path, and the file name. So here it is simply copying whatever file it is simply copying this file to the exploited machine using the ps exec. And also it is executing a bunch of command in the exploited machines using the administrator username and password. In this case, in this way, they can register the tasks as the system, and also they can change the firewall rules as well. Now okay, so we also need to go there. And if you look at here, it will execute the exploits and do everything if it in this IP. And also it does one thing in that IP. It will go for the CSQL function, and here it is scanning for the Microsoft SQL Server. If you look at here, Microsoft SQL Server, and if the SQL Server is present there, it will return 1. Also here it is checking the marker port. It is checking whether the target machine is already exploited. So if it is already exploited, then this port will be opened and it will do nothing. It will just pass from here. Otherwise, if the target machine is not exploited by the SMB vulnerability, it is just going to scan the Microsoft server, MySQL server, and then it will try to brute force the weak username and password. If it succeed in brute forcing the username and password, it is going to execute this query, which is going to enable the CLR, and it will also enable the CLR store procedure with this script. And then here it is adding the CLR assembly into the into the Microsoft SQL server. And after that, here it is creating the procedure and linking it with the evil CLR. And the procedure that it is creating is the exec command, and the command net user administrator k8dj. So here it is also executing this command to change the administrator user password, and running this, and it is also running this script there, downloading and executing the script there in the IP, in the targeted IP or machine. So let's just go over here and look this again. So first it will validate using the username and password in the validate function, and then it is going to check the IP for the vulnerable SMB server inside this function, and it is going to exploit the vulnerable server. And if it fails in exploiting the vulnerable server, then the last thing that it does is, let's say this fails to execute the IP, the target machine with the SMB exploit, then it is simply going to go to the CSQL, and here it is checking whether it is already exploited by the SMB vulnerability, eternal blue exploit. If it is exploited, then it will return 1. Otherwise, it will return 0. If it returns 0, that means it is not exploited. The exploitation didn't work. The eternal blue exploit didn't work, so it goes through this technique. It will register the evil CLR assembly and create the procedure and execute this command. So here they are also expecting that the user that they have brute force has the enough privilege uh, to change the username and password. So but it is not 100% true most of the time. Like the Microsoft SQL username and Microsoft SQL user, which is assigned to the Microsoft SQL server, they might not have permission to change the username and password. So here again, it is doing the same thing. It is scanning and then scanning for the port 445 and then doing the ps exec after the username, after the password is changed. It is again executing these bunch of commands in using the ps exec and copying the dl file over there in a targeted machine. So this is the I think we should end this now. Okay, so we did a little bit analysis in the sample, and we will be dropping this sample when we upload this session in the YouTube. So we will be dropping the sample as well, so that you guys can download the sample and analyze the sample by your own. And also we are not dropping the sample that we just analyzed, the Python script that we just analyzed. We will be dropping the original sample that we got in our server, in our vulnerable server that we exposed in the on the internet. So we will be giving this sample. So you will be extracting the Python script from there, and you can perform the analysis from there. So thank you everyone for joining this webinar. I hope you guys have enjoyed, or maybe some of you get bored, but yeah, this is the end of the webinar. So if you guys have anything to ask, then you can ask your queries. Yeah, actually, this is the first part is the theory, and then we also analyze the sample. It's just we did a static analysis, that's why it's really hard to understand. So in that case, we are also dropping this recorded session in a YouTube, and also we are dropping the malware sample, and you can rewatch the video and do the analysis on your own as well. Yeah, so for the Python, so we will be dropping the binary, and there is a tool called, I think it's a instructor. So this is the tool. You can simply use this tool to extract the Python file, and then using the uncompile, you can simply uncompile the main binary. Sorry, the decompiled. Sorry, the extracted Python PYC files. Okay, we are just, let me just drop this. You can simply use this py instructor to extract the py installer generated executable file, and you will be getting pyc file, and the main file will be i.pyc, and using the uncompile 6, you can uncompile this file and then convert this in the original form like this. Yeah, there will be download link available when we update the video in the YouTube. In the description, we are going to provide the link to the file. Okay, actually, the references for the references, we actually only use the MITRE framework to map the techniques there, and we use this couple of tools, but we will be adding that in the slide, and after updating the slide, we are going to provide the slide as well. So the honeypot setup was like it's in the testing phase. What we did was we set up the vulnerable server. We set up bunch of vulnerable servers and services in the system in the server, and then we just expose that to the internet. So we are still in the test phase for creating that honeypot kind of setup. Yeah, you are getting the certificate of attendance. So once we upload the video, we are also going to share that video in our social media. So you can simply go there and then download everything related to this session. So just keep updated to the to our social media platform. Yeah, actually, you can give a feedback uh, in our email. So let me just drop the email here. So you can just email the feedback in that support email. Yeah, actually, the blob that we saw in here, let me just go over there. If you look at this blob, this is actually the encoded with the 64, and actually it is compressed with the deflate stream. Just let me. this deflated stream, and so this is the actual output. If you look at here, so this is the actual deobfuscated version of that file. But actually, if we figured out that it is this script that they are using there. So this is the same script that they are using in here, but they have obfuscated the names and all. But this is the same script, and this script reflectively loads the mimikaz into the memory. So here's it, and let me just copy this. So if you look at here, the argument is the secure LSA and login password. I think we can also find this here. If you look at here, it's the same thing. It's the same code, but it is a little bit obfuscated. And this is the stage 2. Stage 1 looks like this. This is stage 1 of the deobfuscated, and we again deobfuscated that to get this script, and later we figured out that it was using the version the invoke mimikaz from the power split. This one. So actually today we did the static analysis. That's why it is like a little bit difficult to understand, because we didn't see anything, just the theory here. That's why. You can share the review in the support email so that we can improve our presentations or research in future as well. So you can give the feedback in the support email that that I just sent. Okay, thank you everyone for joining this webinar. Now we should end this webinar. So thank you everyone for joining, and if anything that any feedback that you need to drop, just drop that in the email. And thank you again everyone for joining this webinar.